All right, so here we are about to begin a new video on lists in Python. It has been almost 2 years, probably over 2 years, since I had last recorded a video, and I thought that it would be appropriate to resume this passion of mine. So I'll start from the point where I had left off, which is lists in Python, and it's a different feeling altogether, to be honest, coming back after such a long time. I'd always wanted to carry this on. I remember at one time I was very active. I have already recorded 203 videos, 204 videos, over 200 videos now. But somehow I wouldn't give any excuses, but somehow that habit left me. But this is a new year, and I thought that why not? Why not resume something that I enjoy doing so much, which is teach. So, without further delay, let's begin our discussion on lists. In this video, we will be looking at the functions which are very much in use when it comes to lists. In the previous video, the last video that we had recorded on lists, we had mainly focused on creating a list, slicing lists, indexing lists. You can find that video in the playlist itself, in the playlist on Python that I'm maintaining. In this video, we'll focus mainly on the key functions that are in use when it comes to Python lists. So we'll start off with the append function. And the append function, as the name suggests, it is used to append items at the end of the list. Now, immediately a question comes to mind that what exactly do we mean by items? Here, an item can be a single value, for example, an integer, a string, a floating point value, or it could be a composite data structure like a tuple, probably another list that you want to append at the end of an existing list, a string or a list of strings, and so on. So it's up to you. It depends on the application that you're dealing with, but the flexibility is all over the place. When it comes to the append operation, you can append any item, whether it is single valued or composite, at the end of the list. Also, very importantly, the append operation, it's an in-place operation. That means what will we be doing? We'll be invoking the append function on a list. When we invoke the append function on list, the list on which the function is invoked, the list on which we are invoking the append function, that list will incorporate the change immediately. We do not have to mention anything explicitly. That means the append function will not return anything as such. It's not that it will return a new list and you'll have to reassign that new list to your. You need to It's not that I'll rephrase what I said. It's not that the append function will return any value. It's not that it will return a value and you will have to assign that returned item to another list. It's not like that. You simply invoke the append function on an existing list and the changes are reflected on that list immediately after the function executes successfully. However, when it comes to the append operation, when it comes to the append function, we can append only one item at a time. So we start by appending any item. So that could be a literal, like I said. You could append an integer, you could append a floating point value, a string, or it could be an entirely new list. So we'll look at all these cases as we now progress in the video. So I'll just delete this cell. Maybe I'm a bit rusty. It has been quite some time. I mean, teaching in a classroom and teaching in such a scenario, the two are very different. Anyway, I hope I get the practice going again after a few recordings. All right, let's create an empty list. So I'll call this my underscore list. And as all of you are aware, if you have gone through the previous videos, if you haven't, I would strongly recommend that you do, we can create an empty list in two ways. Either we can use the pair of square brackets that we have used here, and you can verify the fact that your list has been successfully created. How do you do that? You make use of the type. So if you pass the my underscore list to the type function, you find that the value that is returned is list. Similarly, you can create a list using the list function or using the list keyword. Now, how do you do that? You can do my underscore list underscore 2 is equal to list followed by a pair of parentheses. And again, if you invoke the type function on mylist2, you will get back the same output, right? So if you do my underscore list underscore 2, and what do you get back? You get back a list. So you see, there are two ways of creating an empty list. Now, once we have created our empty list, what we'll do is we'll append a few items at the end of the list. So what I'll do is, to this list called my underscore list, I'll be appending a single valued item, and to the list my list 2, I'll be appending another list. Let's see. So let's go to my underscore list. So I'll do my underscore list dot append, and I'll simply append a single valued item. So I'll append 5. So if I append 5, and then if I try to display my underscore list, what do I get? Let's see. So if I do print my underscore list, then what do I get? I get 5. And you see the 5 is surrounded by a pair of square brackets, meaning that it is a list. It is part of a list. Now, can you just append one item at a time? Yes, at a time you can append only one item. But if you're looking to append multiple items at one go, then you can make use of a loop. We'll look at that shortly. But before that, I want to show you how you can append not only a literal, like we have done here, a 5. You can also append another data structure. You can also append a composite data structure. So what kind of composite data structure are we talking about? We are talking about something like another list. You can also append a tuple. I'll stick to lists for now, because I believe, to the best of my knowledge, and if I remember correctly, I don't think I've covered tuples in detail. So I'll stick to lists. I can append a completely new list here. So I can do 3, 4, 5, 6, and list, remember, is a heterogeneous data structure. That means it can contain values of different types. So a list can contain integers as well as, let's say, something like strings. So you could say we could have something like this: few integer values followed by a few string values followed by even, let's say, fractional values. Now, if we try to print my list 2, let's see what happens. So if I do print my list 2, then what do I get? You can see you have a list of lists. Can you see? There is this inner list given by this portion that I've highlighted, and this is inside my actual list, which is my list 2. So what has happened? An entire list has been appended to my list 2. Now what you can do is you can append more items. So I'll show you. So let's say I do my underscore list underscore 2 dot append, and let's say I append another string. Let's say hello. And now if I display my list 2, what do I get? So if I display my list 2, you see, hello, this new string has been appended at the end of the list. And this is the meaning of in place operation. Can you see? I'm invoking the append function, and I'm passing an argument to it. I'm passing a constant to it. This constant denotes the item that I want to append at the end of the list, and it's not returning any value. The changes are being reflected on my list 2 itself. The function append has been invoked on my list 2, and the changes, the new items, are being appended at the end of my list 2 itself. So it's not that I need to create a new list and append will return a value and I'll have to assign that return value to the new list. No, it's not like that. Append works on the list on which the append function is invoked. The append function works on the same list on which it is invoked. So here the append function is invoked on my list 2. So it appends the item at the end of my list 2. As simple as that. Now you can also append multiple values using loops. So let's do that. Let's say I want to append. So I have, if you remember, I have this list, my list, which contains just one item, 5. I want to append, let's say, the first 4 natural numbers, 1, 2, 3, 4, to this list. So how do I do that? I cannot. So if I use append, I'll have to do it one step at a time. So I'll have to invoke the append function 4 times, and I'll have to pass each of the natural numbers when I'm invoking the append function. But now I'll be making use of a loop, and repeatedly I'll be calling the append function inside the body of the loop. Have a look. So I want to append how many values? I want to append 4 values. So if I want to append 4 values, I need to invoke the append function how many times? 4 times. And I'll be keeping this invocation of the append function inside the loop. So what I do is for I in range 4, and here my list is what? My underscore list, and I'll do dot append, and I can make use of this variable I. So I starts from 0. So all I need to do is I need to do I plus 1. What did I say? I want to append 4 natural numbers. I want to append the first 4 natural numbers at the end of the list, which is why, so natural numbers start from 1, and in this loop statement I starts from a value of 0. That's why I have to do this I plus 1. You can also use a separate variable which will act as the list item to be appended, but I thought why not reuse the variable I itself. And if I execute this cell and then print out my list, as you see, 5 was already there previously. Now I have managed to successfully append 4 more values, 1, 2, 3, 4, the 4 natural numbers in the same order. So this is what the append function is all about. Let's move ahead. Let's look at another function. Let's look at the clear function. What will the clear function do? The clear function will simply take all the list items and remove them from your list. However, it will not free up the list from the memory. That means the list object will continue to reside in memory, but the list items will no longer be present. Let's see. So we already have created 2 lists. We have my list, this is the one, and we also have my list 2. So there are these 2 lists which are already there with us. Let's say I want to clear up my list 2. I want to clear it up. All I need to do is, again, this is also an in place operation, which means the list on which the clear function is invoked, the clear function would be applied on that list itself. If I invoke the clear function on my list 2, all the values present in my list 2 will be removed, and my list 2 will now become an empty list. It started off as an empty list, so it will go back to being an empty list again. So let's see. So if I do my list 2 dot clear, I don't need to pass in any argument. The clear function does not expect any argument. It takes no parameters. Now if I print out my list 2, see what happens. You see, we get back an empty list. This is what we had started with. So that is the clear function. Now let's look at the next function, which is sort. As the name suggests, it is used to sort the elements of a list in a predefined order. By default, this predefined order is ascending order. So if we don't mention the ordering, it will be in ascending order. However, if we want, we can make use of the parameter called reverse, and if we set it to true, if we set the reverse parameter to true, then the sorting will occur in descending order. However, there is a caveat, and that is you have to be a bit careful regarding list sorting. Remember, lists are heterogeneous data structures, which means you can have elements of different types. Now, if you try to sort a list which contains a mix of integers, floats, and strings, you will get an error. I'll show you that. Let me show it to you. So let me show you the correct thing first. This is my list. This is a perfectly eligible list for the sort operation. So let me show it to you. So if I do, and mind you, this is also an in-place operation. This is also an in-place operation. That means if I invoke my list, if I invoke the sort function on my underscore list, the sorting would be applied on my list itself. So if I do my list, sorry about that, my list dot sort, and now if I print it out, you see I did not pass any value for reverse. Which means the default reverse value, which is false, was used here. So what should happen? The sorting should take place in ascending order. So if I print out my underscore list, and as expected, we get the values in ascending order. Let's say I want to sort my list in descending order. What do I do? Again, I'll write the name of the list, I'll invoke the sort function, and I'll set the reverse parameter to be false. If I set it to false, again, I don't get back any output. The function does not return any value. However, the changes have been reflected in the list itself, which in this case is my list. And now if you see, oh, I'm so sorry, I did reverse equal to false. It should be reverse equal to true, isn't it? Reverse, if it's reverse equal to false, then it's in ascending order. So if I do reverse equal to true, there you have it. So I have my list now sorted in descending order. Let me show you the incorrect operation. That means if I try to sort a list containing heterogeneous values, let's create that mylist2. So we have mylist2, right? And let's say I want to append number of values. Okay, let me append it one by one. So if I do mylist2 dot append, and let's say I pass 1, let me copy this. Okay, what just happened there? Just a moment. So mylist2, I'll append 4 items, right? So let's say I append an integer, I append a floating point value, I append a string. Let's say I append another list, 1, 2, 3. Or let's take bigger numbers, 100, 200, and 300. So these are my new items which are now present in my list 2. So if I print my list 2, you see what happens. So I have my list successfully appended. Now if I apply the sort, have a look what happens. So if I apply the sort on my list 2 dot sort, and there you have it. So here you get a type error saying that you cannot compare strings and floats naturally. You could still sort a list containing integers and fractional values. However, you'll never be able to sort a list which contains numerical values as well as strings, because there is no way you can compare the two. There's no way you can compare numerical values with your string values, and on top of that you have another list itself. So this is beyond the capabilities of the sort method, which is defined in list. Maybe you could try and modify the sort method so that it could probably incorporate string sorting as well, where you could make use of the unicode values and then do the sorting. Maybe that is an exercise that you can try thinking about. Anyway, I'll move ahead and look at the next function, which is count. What the count function does is it simply returns the number of items that are present in a particular list. So what you do is you simply pass a value to the count function and you invoke the count function on a list. It will give you back the number of times or the count of that particular item present in the list. So let's see. So let's say I think I already have my list, but you can see there are no repeating values. I mean, it's in order to demonstrate the count function, if we have repeating items, then it would make more sense. So if 5 occurs 4 times, 4 occurs 20 times, then you would be able to look at the output and understand things that, okay, the count function is actually working, because in my list, all items have a count of 1. So let me do a bit of modification. What I'll do is I'll take help of the loop that I had written earlier. Where is that? Yeah. So I'll bring this up and I'll paste it. Where did it go? Yeah, here it is. So I'll paste it here. I'll create a new cell. Let's say I append the same value. Let's say I append 10 times to my underscore list. Now if you look at my underscore list, see how it looks. Have a look at my underscore list. There you have it. So you clearly see that 10 fives have been appended at the end of the list, and there is 1 5 which is at the beginning. That means there is a total of 11 fives in this list. Now if I use the count function on this list, my underscore list, so if I say my underscore list dot count, and if I pass 5 to it, you see I get back 11, which is the correct answer. You can pass in any other value as well, which is present in the list, maybe 1. The item 1 occurs only once in the list. What about 100? 100 is not there in the list. you get back 0. You don't get back an error. You don't get back an error. If you pass an item which is not present in the list, if you try to count an item which is not present in the list, you get back 0. Are we clear on this? I hope we are clear on this. Let's move ahead. Let's look at the extend function. The extend function, what it does is, it will append multiple values from an iterable which is passed as an argument. So this is different from append. When it comes to append, what you do is you take an object that could be a composite object like list, tuple, or it could be a single valued object. For example, literals, integer literals, string literals, float literals, and so on. So you append that. You append the entire object, whether it be a literal object or whether it be a composite object, at the end of the list. You do that. Now, when it comes to extend, what you do is you have an existing list. For example, I have my underscore list 2. I have my underscore list 2. This is my list. And what you can do is you can extend this list. So how can you extend this list? You can extend this list by passing an iterable to the extend function. So if I pass, let's say, another list 1, 2, 3, 4, 5, if it would have been the append function, then what would have happened? This entire list would have been appended as a separate item at the end of my list 2. This entire list would have been present at the end of my list 2 as a separate item. But here, when it comes to extend, what it will do is, it will simply extract each element from the list, and every element will be appended one after the other at the end of my list 2. Have a look. Now, if I print my list 2, see what happens. So if I do my list 2, there you have it. See, this is the difference with append. What append would have done is, it would have taken this entire list, and added the entire list as an item here. It would have added it as an item here. Extend, what it's doing is, it's extracting every element from this list. So it's extracting 1, it's putting it at the end of the list. It's extracting 2, and it is putting it at the end of the list here. It's extracting 3, putting it at the end of the list here, and so on. This is the difference between extend and append. And you could do this not only with lists, you could do it with any other iterable. For example, if I do, in fact, I could just remove this. So if I try to extend my list 2, let's say with a tuple, the same thing will happen. So I'll pass in few big values, so 100, 200, 300. And if I try to print my list 2, let's see what happens. If I try to print my list 2, and you see the same thing has happened. Every value has been extracted from the tuple and appended at the end of the list. So in a way, you can say that the extend function takes the help of the append function, extracts every item from the iterable that you're trying to extend your existing list with, and it appends it to this existing list on which the extend function has been invoked. Go through that last 10-12 seconds that I just spoke about. I think you will be able to understand the difference better. Moving ahead, let's look at the index function. The index, as the name suggests, it simply returns the first occurrence of a particular item that you pass as an argument to the index function. And mind you, only the first occurrence is returned. So if your list contains duplicate items, the duplicate elements, that means the second occurrence onwards, will be ignored. Only the first occurrence index would be returned. So if we do something like my list, so what is my list? This is what it is. And here, if I do something like my list dot index, and if I pass 5, what do I get back? Guess? 0. See, we get back 0 because the first occurrence of 5 is at index 0. There are other 5s as well. Starting from index 5. However, the 5s which are starting from index 5, these 5s are not the first occurrence. The first occurrence is at index 0. So you get back 0 here. Right? Great. Now, let's look at the insert function. Okay, what if I try to find the index of an item which is not there in the list? Then what would happen? Count returns 0, if you remember. If I try to find the index of 5000, 5009 perhaps, see, I get back an error. Index returns an error because 5009 is not in the list. However, if you could recollect, when we were looking at the count function, count would not return an error. It would simply return us 0. That means this item has a count of 0 because it is not present in the list. So that's the difference between your count function and your index function. Next, we are left with just two more functions. The insert function. What the insert function will do is it will insert an item at the position that you request. And you can insert value of any type. So again, it could be a literal, it could be a composite data structure. So if I look at my list, this is my list, and I could insert, so I could do my underscore list dot insert, and I could say insert at index 0. Please insert a new string. And again, this is also an in place operation. And if I print my underscore list, you see a new string has been inserted. This is what I wanted to insert. So you pass in two arguments. The first argument is the index at which you are looking to insert, and the second argument is the value that you're looking to insert at this index. So I'm looking to insert a string which I've highlighted here at index 0. So that string has been inserted successfully at index 0. Okay. Next is the pop function. The pop function, what it does is it removes an item from a list, and it also returns that item from the list. And by removing, what we mean is it is completely gone. It is extracted from the list and it's no longer there. And here you can mention the index as an argument. So you could say that, okay, I want to remove an element from index 3. So it will remove that particular element from the list. However, if you do not mention any index, even that is possible, it will take the default index to be -1 and it will remove the last element from the list. So let's have a look. So if I look at my list again, so this is the one, and let's say I invoke the pop function on this, and I want to remove this item. I want to remove this string which is there at the beginning of the list. So what I do is I pass in 0, and you see this item has been removed and it has also been returned. What I can do is I can now verify this by printing it out. So if I do my underscore list, now you see a new string which was previously there is no longer present. And what if I pass in, so let's say I append one more value so that you understand what's going on. Let's say I append a big value. So let's say I append 5000. And now if I display my list, let's see what happens. If I display my list, yeah, so you see the big element 5000 has been appended successfully at the end of the list. Now I want to remove this one. I want to remove 5000. What I can do is I could simply invoke my underscore list dot pop, and the element has been removed and it has also been returned. So if I print my list, now if I look at the content of my list, there you have it. My list no longer contains 5000. Here I did not pass in any index. So by default, it popped out, it removed the rightmost element from the list, which in this case happened to be 5000. Alright, so let's look at the remove function. I believe there are a few more. I had said that only two functions are left. Anyway, let's look at the remove function. Remove works similar to pop. The only difference is it does not return the element which has been removed. So pop, both the functions pop and remove, these are in place functions. However, in case of pop, the value that was being removed from the list was also being returned. But when it comes to the remove function, the element that is removed is not returned. So it does not come out as an output. It simply happens on the list itself. The element is removed from the list itself, but it does not get reflected as an output. So let's see. So again, this time let's work with my list 2. So if I look at my list 2 here, this is the one. So what it will do is it will remove the first occurrence of the element with the specified value. So let's say I want to remove hello, and there is only one occurrence of hello. So if I use that, so if I do my list2 dot remove, and if I pass in hello, you see no value was returned. However, the element has been successfully removed. You can verify it. So if you do my list2, now you find that there is no hello string in the list. Right? Fair enough. Now coming to the last function of this lecture, of this video, which is the reverse function. The reverse function, as the name suggests, it does not accept any arguments and it simply reverses the elements of the list. And it will return the reverse list, mind you. So if I do my list, this is my list, or let's look at my list 2. This is my list 2. And now if I apply my list2 dot reverse, yeah, so here if I try to print my list2, I see that the elements have been successfully reversed. So no value is being returned. So there's a mistake from my end. It does not return the reversed list. Yes, it does not accept any arguments, that is true, but it simply reverses the elements of the list, and it is an in-place operation. It is an in-place operation naturally because no value is being returned and the operation is being applied on the list on which the function has been invoked. So in this case, the function has been invoked on mylist2 and the reverse has been applied on mylist2 itself, as you can see by looking at the output. So this is also an in-place operation. Right, so I guess that video got a bit lengthy, and my recording, I don't know how it has come out to be, but as I have always requested all of you, those who watch the videos, that if you found the video useful, you could give it a like. If you have any queries or any suggestions to offer, feel free to comment and subscribe to this channel. Share it with other people if you found this video useful, and if you think that the videos that I make are of good use to you. And I promise I'll be more regular this time around. I'll record more videos and I'll try to spread knowledge to as many people as possible. So thank you for your time. I'll see you again soon. Bye bye.